Soil porosity is closely related to the soil texture and structure. This demonstration is going to show what happens to the porosity of a soil as the particle size gets smaller. Now I have a sponge because it's easy to cut, and so because the sponge, I know the sponge does have some pores in it, but we're going to ignore that for now and assume it's a solid material, just like you would have a solid piece of rock being made smaller into a smaller texture. So what I'm going to do is I'm going to take my knife and I'm going to start cutting this sponge up into smaller and smaller pieces. So we'll start off by cutting in half. Okay, and then we'll keep cutting the sponge up until it's small pieces. It may take a while, so bear with me, and I'll probably cut to reduce the time you have to spend looking at me cut up a sponge. Okay. I have gotten to the point now where I'm done cutting, so at least this batch, and you can see that the pieces are roughly the same size as each other. Essentially, we've gone from a very large single piece of sponge, this size, and we have gone to this size. Now, if we were to take a look, let's say I dump this chopped up stuff out, and I will. Just stick it over there. Put the sponge in. The sponge that I started with, this is approximately half of the sponge. The sponge I started with is definitely taking up less volume than when I fill it up with the chopped up bits and pieces of sponge. Okay. Now I could go on and chop this sponge up even more, but I'm not going to do that in the interest of time and my fingers. I'm not going to chop it up any smaller, but you can see that as the pieces got smaller, the sponge, the volume of the sponge actually increased because there's more pore space, there's more porosity inside the chopped up pieces than we have in the solid piece of sponge. And so the smaller the piece, the more volume it takes up, the more porosity it has. So as we go from sand to silt to clay, we're going to get more and more volume in the soil, more airspace, more porosity, more pore space, and even though we have the same volume of solid material, we are going to have we increase the amount of pore space as we chop things up. Now, the way I can explain that is if we go back here to this one sponge, and if I were to take this sponge and cut it in half, I don't know, I already did that, but if I were to cut this half in half again, so I had a quarter, no matter how hard I tried, I would not be able to fit the two pieces back together absolutely perfectly. There will be some airspace in between those two pieces of the sponge, and so so that means there's more porosity. Every time I cut the sponge up, okay, in each direction, I can just keep cutting and cutting and cutting. Every time I cut the sponge up, I'm introducing a little bit of pore space every single time it gets cut. And so the more times you cut it, if we're going from this sponge, which is quite large, it's larger than sand, it's gravel sized. If I were to take this sponge and cut it up into clay sized pieces, which remember are less than 0.002 millimeters in diameter or 2 microns in diameter, so that would mean a lot of cutting. But if I were to cut it up into those small pieces, every time I cut, I'm introducing more and more pore space. And so the smaller particles are going to have, smaller textured materials are going to have more pore space in them, and the bulk density will be lower, and given the same volume of solid material. I'm not changing the volume of solid material. What I'm doing is changing the total volume or the volume of the pores. As I cut it up into smaller pieces, we get a bigger volume and more, it takes up more space, more volume, lower bulk density because there's more pore space. So that's the relationship between texture and pore space. As the texture gets smaller, the pore space is going to get bigger and increase.